Zero is my hero.
Welcome to the adventures of Math Girl. With the help of Pocket Ronnie, you also can become a trusty sidekick of Math Girl like PreCalculus and the Daring Derivative.
Counted on our fingers and toes. Now you're here to stay. And nobody.
Okay, we're doing vectors. Here is a summary of what we will be doing with vectors. In vectors, you're going to start out with r and theta, a coordinate in r and theta. We're basically going to be taking those coordinates and converting those into rectangular coordinates. Then we will add or subtract, depending on if you're adding your vectors or subtracting them, the x component of each vector and the y components of each vector. Then once you have your final x and y component, take that rectangular coordinate and then convert it back to r theta to polar coordinate. The one thing to remember about vectors is to draw a picture, because a picture will help you know what quadrant you're in so that you get the correct final angle and you don't use the reference angle. Okay, we're looking at 18C2. We've been given a first throw and a second throw, and we are wanting the resultant. When you're given the first and the second, you basically are adding those two vectors together to get your resultant vector. So basically vector 1 plus vector 2 is equal to the resultant vector, okay, when you're given a first throw and a second throw. My recommendation is to always draw a picture. Okay, so our first throw is 4 miles at negative 25 degrees. Negative 25 degrees means we're in quadrant 4, so that's somewhere like in here. And the length of this is going to represent 4 miles, and then this is 25 degrees. Okay? Then it says the second throw is at 4 miles, 280 degrees. The one thing about vectors is that they are drawn head to tail. So it's like we just threw a frisbee to right here. We're standing here, and now we're about to throw the frisbee again. So you need to make a new XY axis right there. And so you're standing there at the origin, so now you're going to throw it a second time, and you're going to be at 280 degrees, which is now going to be in quadrant, that's also in quadrant 4. So about right here is 280 degrees, and it's 4 miles. So since that's 4 miles and length that represents 4 miles, I want them roughly the same length. Okay, so that would be 4 miles, and then starting at 0 going all the way around would be 280 degrees. Okay, so then our resultant will always be from the origin, so this is the resultant. When you add these two vectors together, then starting at the origin to that finishing mark is the resultant. Okay, but what you can do here is you can break this up into two different triangles, two different right triangles. So with my first throw being right here, I'm going to draw this with the green triangle. I have that, so I can draw it into this triangle right there, that green right triangle. This would represent my x direction, that represents my y direction. Okay, with my second throw, I'm going to use orange triangle. So that's here, that's my x direction, and then going down to my y direction. I have drawn two right triangles. That is my x for my orange triangle, this is my y direction for my orange triangle. Notice that here, this x I went in a positive direction, this y went in a negative direction. We will keep track of that here in a minute. Okay, so essentially what we're doing is we went here for our x direction, then we went another distance over here. And that would really add up to our resultant. Going over here in the x and a little bit more, see our resultant ends here. Same with the y. We go down and then down some more, and that's the whole length of the y for the resultant vector. Okay? So the way that we can calculate this is you just look at one triangle at a time. For now, we're just looking at the green triangle, which represents vector 1. Okay, so this was the first vector, 4 miles at negative 25. Okay, so for right now, we are looking at the green triangle which is vector 1. Okay, that's vector 1. So what we need to do is take this polar coordinate and convert them into an x and y coordinate. Okay, we have already done that. We use the relationship that x, because we can use sine and cosine. Okay, and if we do that, then we came up with this relationship of x equals, take your r times cosine of theta. For your y value, y is r sine theta. And that all comes from cosine is adjacent over hypotenuse. Remember, r is the hypotenuse, and sine is opposite over hypotenuse. That's where those equations came from. Okay, so applying our numbers in our triangle, again, we're just looking at vector 1, which is this green triangle. So x is equal to my r, the length of my hypotenuse, is 4 miles, times cosine, and then my angle is 25 degrees. Okay, doing that, and I'm just putting all my answers to 2 decimal places. That came out to 3.63. To determine my y distance of this triangle, I can do 4 sine of 25 degrees, and that comes out to 1.69. But the one thing to notice, if I start at the origin, I went in the positive x direction, so this number should be positive. Then I went in the negative y direction to get to this point right here. So this needs to be negative. You need to look, this is why it's important to draw a picture. You need to make sure that your numbers match your graph, match your picture, okay? So I can rewrite vector 1 as this. Vector 1, I'm going to write this with x and y coordinates. I went 3.63 in the x direction, and then I went down 1.69 in the y direction. So this vector can be written in this format, and all this is saying is 3.63 in the x direction, a positive 3.63, and then I went negative 1.69 in the y direction. So I have now written this vector in an x and y format, okay? Now we need to do the same thing with the orange triangle, which was vector 2. So that's vector 2. So I'm going to be doing the same thing, okay? So my x value is the length of my hypotenuse, which was r, which was 4 miles in my case, cosine of, and then my angle here, I am looking at, starting at 0 all the way around here was 280 degrees. Or I can look at that reference angle, which was 360 minus 280, which would be 80 degrees. So I'm going to show you 2 different ways that you can do this, okay? You can either say 4 cosine of 280 degrees, which that's what was given in the problem, or you can say x equals 4 cosine, and then you can use the angle that's just inside the triangle, which would be 80 degrees. One of them I'm using the whole degrees that was given, the other one I'm using the little angle that was given inside the triangle, okay? They will actually come up with the same answer. The difference is you have to put your signs in there, okay? So this comes out to 0.69. This also comes out to 0.69, okay? Let's do our y values for the orange triangle. So y is going to be 4 sine of 280 degrees, or you can do y equals 4 sine of 80 degrees. This is given in the problem starting from 0 all the way around clockwise. This is just the angle inside the triangle. These two add up to 360. This is where you can see the difference. If you do y equals this, then you're going to get a value of 3.94. Your calculator will give you a positive value, but you look at the graph and you see you went down in the y direction, so therefore that needs to be negative. If you use this in your calculator actually automatically does the negative for you. The calculator knows that 280 degrees is in quadrant 4, and it knows that sine is negative in quadrant 4. So your calculator will actually do it for you and give you the negative value of 3.94. Okay? So therefore, vector 2 can be written as, if we want to write it in our XY format, it's easier if you do this. We went 0.69 in the x direction, a positive 0.69. Then we went negative 3.94, meaning we went down in the y direction. okay? How do we get our resultant vector? We get our resultant vector because we're going to take vector 1 plus vector 2 is equal to the resultant vector. So let's write out vector 1. Vector 1 was 3.63 in the x direction, and then we went down 1.69 in the y direction. Vector 2 was 0.69 in the x direction, a positive, and then a negative y direction. We are adding these two vectors, okay? You can only add x's to x's and y's to y's. Add your x components together. When you add your x components together, then you get 4.32 in the x direction. Adding your y's, in debt means you're still in debt. That would come out to 5.63 in the y direction. Now, what do we have here? We actually can go back to our original picture, but let me draw a picture down here first. I recommend redrawing this. What does this mean? This means that our resultant vector went a positive 4.32 in the x direction. Positive 3.2 in the x direction means, I should have grabbed a different color, means we went 4.32 in that direction. Then we went down 5.63, okay? We went 4.32 in the x direction, then we went down 5.63. Starting at the origin here, that will give us the r value of our resultant vector. This line right here, the hypotenuse, represents our resultant vector. Then we also need to find our theta value, because what we're doing is taking these rectangular coordinates, which is an x and y coordinate, and now converting those into an r and theta, okay? And if you go back up to our original picture, this actually matches our resultant vector. We went in a positive x direction, then we went down in a y direction to get to this final point right here, okay? So here's what we have here. So we're taking this x and y value and now converting them back into an r theta. We want our final answer to be in polar coordinates. So how do we find r if we know x and y? Pythagorean theorem. Okay, so r squared equals 4.32 squared plus 5.63 squared. I normally go to 2 decimal places. Trig functions are to 4 decimal places, everything else is 2. So doing all that, then r is going to be 7.10, and this has a unit to it. This is a distance. So if you go back to the original problem, the distance that we have been given was in miles. So therefore, that's the length of our vector. Okay, so now we know the length of the vector, the hypotenuse. We have to find the direction, the angle. Okay, so basically we're looking for this theta. So here, tangent theta is opposite over adjacent, so 5.63. I do not have to include my signs. The sign just tells me I need to go down. So I don't have to include the signs when I'm doing my tangent. I just need to include the numbers. So going through all that and the arc tangent, then theta comes out to 52.5 degrees. Now just remember, that is the angle inside your triangle. That means that is 52.5 degrees. How do we state this to where that we will know we're in quadrant 4? Okay, because this vector is in quadrant 4. There are 2 different ways you can write this answer, because we're going to write it in the r theta format. So it can be written as 7.1 miles, and then to know we're in quadrant 4, that means we can go a negative 52.5 degrees starting from 0. Or it can be written as 7.10 miles, and if we want to go the other direction, this was our clockwise direction, or starting from 0 and going counterclockwise, we can do 360 minus that, which would come out to 307.5 degrees. So again, our final answers are going to be written in finding r, the hypotenuse, and then the angle, the direction that that vector is going. And it can either be the the clockwise direction or the counterclockwise direction. Okay, we're looking at 18C3, and we are given the first vector of 175 meters at 240 degrees. Then we are given the resultant, that's 300 meters long at 272 degrees. Here, this is a big thing to watch for. Are you given the first and second vector, or are you given the first and resultant? So the question asks that we are determining what the second vector is. So in other words, we know the first vector. If you know the first and the second, then you take vector 1 plus vector 2, and that equals the resultant. But here we know vector 1, we know the resultant, and we don't know vector 2, so therefore we're solving for vector 2. How do we solve for vector 2? We have to subtract vector 1 over. So vector 2 is going to be the resultant minus the first vector. This is going to be a key component here in a little bit. So to find the second vector, you take the resultant and subtract the first vector. Okay? So I've drawn the first vector here already at 100. That's 175 meters long, and then it's about 240 degrees. Now when we draw the resultant vector is always starts at the origin. Always, always. So we need to be about 272 meters, or 272 degrees and 300 meters long. Well, 300 is longer than 175. So when I draw my 300 line, it needs to be longer than this line right here. And I'm about at 272 degrees. I have to exaggerate a little bit. So we're just going to say that that represents 300 meters, and starting at 0, that would go around 272 degrees. Okay? So vector 2 is drawn from the head of vector 1. They're drawn head to tail. So they're drawn like this. So this would be vector 2. This is my unknown, and this is at a new origin right there. So we can see that vector 2, the angle is going to be in quadrant 4. So our final answer needs to match to where that angle is in quadrant 4. We can do the same thing as before and separate these into two different triangles, okay? So we're going to separate vector 1 into its own triangle like that. That was a horrible triangle. This is my x value, and you can tell we're in the negative x direction, and that's a y value, and that goes in the negative y direction. For the resultant, I can break it up into a right triangle as well. Now, there we go. So here I go in the positive x direction and then go down in the y direction. Okay, so we're going to change our polar coordinates into rectangular. So for the first vector, okay, this is going to be the green triangle, which is vector 1. So we have a triangle right here, and so we need to find the x and y value of that. Okay, so still using the x equals r cosine theta or y equals r sine theta, still using those relationships. So x equals my r. The length of the hypotenuse is 175 times cosine. You can either use the angle that they give you, 240 degrees, or you can use the angle that's in the triangle. Okay, that angle that's in the triangle, that would, because all the way from here to here is 240, so what's in the triangle would be 240 minus 180. Okay, if you use the 240, then your calculator will already tell you that that x is going to be a negative value. If you use just the angle, the reference angle in the triangle, you need to put a negative sign on there. Okay, so I'm just going to go ahead and use 240, so that comes out to negative 87.5. Y is 175 times sine of 240 degrees, and that comes out to negative 151.55. So I'm going to rewrite this in the format that vector 1 is equal to, writing my which way I went in the x direction, and I should have gone in a negative x direction and then a negative y direction. So I can rewrite my vector in that format. Okay, so now let's do the resultant, which is the red triangle. So this is my resultant vector, r for resultant. Okay, So x is going to be, my resultant vector is 300 meters long times cosine, and that angle was 272. I can just use straight that angle because in my calculator will already tell me if that's positive or negative. This one should be a positive value because that matches my graph. So that comes out to 10.47. Then you have y is 300 times sine of 272, and that value should be negative because I went down in the y direction to get to that point, and that comes out to negative 299.82. So I can rewrite this. My resultant is a positive with a positive x direction and then in the negative y direction to get to that point. So I can write it like that. Okay? So how do I get the second vector? I take the resultant minus the first vector, and that gives me the second vector. So it's important to write them in the correct order. The resultant minus the first. So I need to write the resultant first, which is 10.47x, and then down in the y direction. Then my vector 1 was negative 87.5x minus 151.55y. Here is the important part. I'm subtracting these two vectors. So I'm subtracting that. This is very, very important. I'm taking this whole thing and subtracting that whole thing. So it's very important to put parentheses around there because now this negative has to get distributed to everything in here. The subtraction sign has to get distributed to both of these components. So that becomes a positive and that becomes a positive. That is a very key thing, or your signs will be wrong and your final vector will be wrong. Okay, now taking a positive 10.47, adding it to an 87.5 because I want to add my x's together, then I'll get 97.97 in the x direction, a negative 299.82, and then a positive 151.55 of adding my y components comes out to a negative 148.27 in the y direction. That is my components, my x and y components for my second vector. I normally like to redraw my picture so I can see what it is I have. Earlier I said the second vector should be in the fourth quadrant. So if I go over in the positive x direction a 97.97 and then down 148.27 because that's negative is down, then that is my x direction, that is my y direction. So this would be my hypotenuse, my r value that I'm looking for. So this is 97.97. This is 148.27. I went down, so it shows me on there that I went down. I went there and there. So then I can find my theta. So I have my x and y value. So now I need to find r and theta. How do I do that? Pythagorean theorem. So 97.97 squared plus, at this point I can drop my negative because that negative just told me the direction, equals r squared. So r equals 177.71, and I need to put a unit on there. That was a distance, and at the very beginning we were talking about a distance in meters. So now I need to find my theta. I can use tangent because I know the opposite over adjacent is opposite over adjacent. Using arctangent, that comes out to 56.5 degrees. Again, I would not put your negative signs in there. That doesn't really help you. It actually makes it more confusing. So, but I need to end up in quadrant 4. How do I write this to where I'm in quadrant 4? Either I can say my r, the length of it is 177.71, and then I can say negative 56.5 degrees because starting at 0 and going in a clockwise direction, that will put me at where this line is. Okay, so I can either say it like that, That's one way to say the answer. Or I can say it as 177.71 meters, and then use the counterclockwise direction, which would basically be 360 minus that, and that would be 303.5 degrees. So either way, make sure that your answer will put you in quadrant 4, because that's where we said vector 2 will be.